Hello everyone. This is an interesting day and I would appreciate your patience and attention for a few minutes. So the topic of my presentation is design and analysis of a solar dryer for the rural areas of Bangladesh. I am Anas Khan from Department of Mechanical and Production Engineering, Ahsanulla University of Science and Technology. To introduce my topic, we will have to focus on the problem statement. So what are the problem of conventional drying process? While some agricultural products are dried in an open place, it faces some problems such as sudden change of weather. Sometimes there is sudden rain, sudden increase of air velocity, and dust and dirt falls over the product. Temperature variation happens too much frequently. It is not possible to control temperature outside. Animals or insects attack agricultural products sometimes, and it needs large space and high number of labor. These problems decreases the quality of the product. So to eliminate these problems, indirect force convection solar dryer can be used. So why we have chosen indirect force convection solar dryer? There is a drying chamber which is used to dry the product so that it is safe from the animals, insects, and weather change, and also from the dirt and dust outside. It can be easily controlled, uh, temperature and time, and also the removal of moisture content can be easily controlled. And as a drying chamber, here it needs less space and also less number of workforce. Less number of laborers can handle it easily. To complete this work, we followed some steps. Our initial step was to develop a model with the parameters we found in our study. Then we made a simulation model of the solar dryer and tried to optimize, get higher thermal efficiency. Finally, we worked on the validation of the parameters and the final optimized result we found from our simulation. A drying curve, as illustrated in the figure here, shows how grain moisture content changes over time and how grain temperature changes while drying the paddy. As it can be seen that in this chart, the drying rate is not constant but changes over time. The temperature of the grain also changes over time. Three different periods while drying happens. It need to be understand to dry the paddy in solar dryer. The first stage is preheating stage. Here, this happens because all the heat provided in the drying air used to heat up the grain to dry air temperature. Constant rate period is the second one. Here, water starts to evaporate from the surface of the grain. All the heat from the drying air is used to evaporate surface moisture. Here, grain temperature is quite constant, and the surface water starts to evaporate with the heated air. And the third one is falling rate period. In this stage, internal moisture starts to appear in the surface, and it evaporates with the heated air. Drying rate declines because there is no consistency of this moisture. This stage typically occurs in around 18% grain moisture content. While designing the model, we focused on materials and method. We conducted theoretical study to find out required parameters and components. So here our focus was that the design will be satisfactory, efficient, and it will be built from using materials from local market. We tried to find out the best available options here. Finally, we designed the model based on our findings and the best options. Here is an illustration of our design. In this design, the blower will generate a force convection flow throughout the air passage. The air inside the air passage will take heat from the absorber plate and will enter in the drying chamber. Inside the drying chamber, there will be trays where the wet paddy will be placed, and the heated air will take moisture from the wet paddy and will exit through the chimney. The blower will run using the electricity generated from a solar panel, and it will be controlled by a solar charge controller, and a battery will be used as a storage. To design the solar dryer, we followed several steps. our initial step was to find out the drying parameters. We developed a study to find out what our required parameters are, such as the required heat, required temperature level, and airflow, and what is their optimum level for drying the paddy we are using as a sample. Secondly, we worked on the removal of moisture content. We studied on a paper published by ERI where it refers that for cooking, paddy is need to be kept at 13% moisture content so that it can be kept good for more than 6 months. So we take that as a consideration for our design. Then we worked on designing the solar air collector, which will take air from our atmosphere, and the air will be heated using an absorber plate. The absorber plate will also be kept in the required tilt angle through which it will receive the maximum heat from the sunlight. Finally, we worked on energy balance analysis. Energy balance analysis will be helpful to find out the efficiency of the theoretical results and the practical values. Then we try to validate our computational results. So why it is necessary to validate the findings? It is required to find out the accuracy of our results based on other experimental work. For this purpose, we used INSAT simulation work. This software has a vast database regarding the renewable energy sources throughout the world. It has ability to simulate complex energy projects. Block diagram is used where required parameters were set based on our findings. It contains a large database of solar energy, so it was easy to simulate our design based on any location of the world. We simulated the air passage to find out the outlet temperature. This outlet temperature will be the inlet temperature of the drying chamber. So it was done according to the location of our university, but it is possible to simulate this air collector based on any location throughout the world. The simulation study was then continued for the drying chamber. It was designed using SolidEdge 2021. Mahogany wood was used as a material for simulation. This type of wood is highly available in Bangladesh, especially in the rural areas. Its thermal conductivity it is also low. Thus, the drying chamber will be thermally efficient and the dryer will be cost effective too. With the data provided by Forest Department of Bangladesh, we developed the solid model of the design. Then we worked on mesh sensitivity analysis to find out the optimum mesh for the drying chamber simulation. Seam scale was used for flow simulation of drying chamber. So a comparative study on mesh fineness value was done with the range of 3 to 8, where we found that 7 was the best mesh fineness value. For further experiments, we conducted the simulation using 7 as mesh fineness value. Here is two graph with the result of the simulation of heated airflow inside the drying chamber. Here the first one is of airflow at x, y and z direction. Air enters along z direction and exits along y axis. It shows very little fluctuate of air velocity throughout inlet and outlet zone. And the second one is of temperature variation graph through the outlet. It takes a few seconds to reach at its uniform level, and it shows very negligible fluctuation of temperature level, which ensures uniform temperature throughout the drying chamber. Then we followed some procedure to find the air collector outlet temperature with the INSAT simulation works to find out the effectiveness of our design simulation process. With this study, we found temperature variation for three areas, Dhaka, Rajshahi and Cox's Bazar. This comparative graph shows results of different areas. Result difference takes place based on months, temperature and location, but it shows proper variation of result throughout the procedure we followed. All these results justified the success of the sole purpose of our work, which is to develop a model procedure that could be followed to fabricate a solar dryer for the rural areas of Bangladesh. And also the process can be followed to develop a solar dryer for any location throughout the world. This was the presentation on my topic. Hope you have all enjoyed it. Thank you.